I'm here today with Sagie Davidovich. Sagie is a friend, a collaborator, a partner. He's CEO of Sparkbeyond. He's someone who started on a journey with a dream, and I think you will quickly explore together where he is on that dream journey and what he does today. And I'm really excited, Sagie, for you to join us. Thank you for so doing.
Thank you, Sanjay, for inviting me.
Sagie's in London today. I just met a few months ago in Israel, and we interact and intersect a number of times through the year. But today what I want to cover is a few things. First, I want to tell you a little bit about Sagie, and who better to ask than Sagie himself. So Sagie, in a few sentences, just tell us who you are. Where did you grow up? What do you do? What was your dream? What are you doing today?
Yeah, so I was born in Kiev and immigrated to Israel when I was 7. And since I was a child, my dream was to actually build a machine that can invent. And fast forward several decades, here we are with a company that builds machines that think and come up with creative ideas. So for me, in a way, it's a dream come true.
And that's the key, isn't it? Having big dreams that you can make happen in real life. We'll come back and explore the idea of machines that can invent in a minute. Before I go there, Sagie, just understand a little bit more about you. I know you read, and of course, it's a good time of the year to do so. What's the last thing you've read that you would recommend to us?
So a mentor of mine recommended reading the book called Prosperity by Colin Mayer. And this book really helped me shape my perspective on the role that companies can play in society. It talks about the trade-offs, the relationships, about maximizing value for shareholders, the environmental impact of companies, and the responsibility, social responsibilities that corporates have. And this is a book that I would recommend to everyone.
Excellent. I hadn't heard of that book. That's a fantastic recommendation. And I know we'll come back and talk about social good or working on good as a part of this discussion. I know that's high on your minds and in the minds of your company. Sagie, as you know, is CEO of Sparkbeyond. He's one of the hottest startups in the space of data science and artificial intelligence. We've had a chance to work together for a few years, so I have a little bit deeper insight. But we'll come to that in a minute. Before I go to AI for good as a topic, I want to start a few layers below. For those of us that haven't come across Sparkbeyond, and more importantly than the company, the idea of hypothesis generation, what is all that about? I know you've spent a lot of time in that space, and Sparkbeyond does that. So what is hypothesis generation?
So when we started the journey of building a machine that can ask questions, come up with theories, with hypotheses, we actually had to go very deep into understanding what ideas are made of, which is a semi-philosophical question, if you think about it. AI today, with all the investment in AI, is primarily focused on replicating the human mind's abilities to perceive the reality, whether it's vision, language understanding, speech, etc. At Sparkbeyond, however, we are focused on the complete opposite end of the spectrum, which is giving the machines the capacity to ask questions, to come up with ideas, to create the creative part of AI. In order to come up with the idea, you need this unique combination of some domain knowledge, curiosity, free time, understanding or access to observation, access to data. If you think about it, apples have been falling from trees for tens of millions of years, but only at some point in time, someone asked the question of, can I describe this accelerated motion with a very simple equation? And the question is, why hadn't it happened several centuries earlier? And what could have the world looked like? So just like the Industrial Revolution really systematized manufacturing and production, the same thing has not happened yet with research and ideation. It's still bespoke, and that's what we are after changing.
So it's really interesting, Sagie, because I think all of this know and feel this, but what we're really saying is half of everything we do is about solving a problem or answering a question. And much of what AI we put to use is, here's the question, what's the best answer? What's the best prediction of the answer, right? But I think what you really bring to the table is the other half, which is asking the right question when you come across a problem set, when you look at a set of data. And actually what you're suggesting, and I know this from our discussions, that AI is advanced to the point where you can actually go introspect all the data and all the existing approaches to looking at the data, and through that, generate a set of questions that gets you to asking the right question. Is that a way to think about it? Does that make sense?
Precisely, Sanjay. Essentially, we as humans, we have a cognitive bottleneck. The number of different ideas that we can think of at any given point is very limited by our physiology, as well as bias. We are biased, and we as humans are really bad at managing and being even aware of our own biases. Machines can actually help us with these two. It took us several years, but we are already at the point that the machine can generate around 4 million hypotheses per minute, which actually creates an interesting problem of how do you control for this balance between spurious correlations or making false discoveries versus missing an opportunity to make a discovery. So a lot of the work and our investment is actually in managing this balance.
And so literally, is it as simple as that I can get into a domain area, into a problem space, into a specific real life problem, and literally before I start with I think you call it bias, but even a hypothesis or a point of view that I'm looking to check, I actually take a very neutral perspective and I stand back and I expose it to these different algorithms and these different approaches and techniques in parallel in real time at high speed, and then let the best correlations drive the best hypotheses, which drives the best questions. So the questions are now coming back to me from AI. Is that a very simplistic way of sort of?
Yes, I think this is a precise description. Essentially, the machine would combine different building blocks that can transform the data in different ways to articulate new hypotheses, test them on the data, and then translate them to plain English.
So give me an example of a kind of a problem that this approach would make a lot of sense, like just to bring that to life.
Yeah, so for example, if you want to optimize store locations and you want to basically maximize profitability for these stores, the machine will discover that it could be a good idea to open more stores next to gyms or next to laundromats or next to churches. In different areas, etc. And it would do so by augmenting the data that the retailer would provide with a broad range of external data sources, which is part of what Sparkbeyond essentially brings.
Got it. Now it makes sense because making a decision on where to open one of many retail stores is codependent on so many different variables that the problem of trying to figure out a hypothesis and testing it is almost the wrong way to approach the problem. You actually have to throw all the variables in the equation and then generate from there the best possible hypotheses. And intuitively, that makes sense to me. And it's amazing that what you're saying is that the technology has caught up to the point where we can compute at that speed and deliver that. Is that true? Is that real life? Is that actually happening? Is this sort of what we're planning for the future, or are we doing it today?
Yeah, this is actually a case study from 2.5 years ago, and we're actually after much more ambitious things today. Okay,
so we'll come to that now. I met you a few months ago, I think it was in Tel Aviv when we last met, and you talked to me and you were very excited at the time about this move from sort of this hypothesis generation as a starting point for your company and for industry as a whole into this notion of knowledge mining and kind of this inventions machine idea. Talk to us a little bit about where that part of the world is moving.
Yeah. Hypothesis generation and search and automated research based on data is a very important ingredient. And it's essentially inductive in nature, right? You generalize from patterns that you discover in the data. It's data-driven, it's inductive, it's bottom-up. Can we, on the other end, complement it with top-down, knowledge-driven, qualitative in nature, and deductive processes, where, for example, if you have a certain, let's say, a patient's data set from medical records. This is very sensitive data. And a research has been conducted by a researcher on that data to discover a link between a certain gene and a certain disease. Now, since the data is sensitive, the data has never been released, but this bit of knowledge, the fact that this link between the gene and the disease has been published as a scientific article. And this is the difference between data and knowledge, right? So can we actually start mining all this knowledge that exists on the web, essentially humanity's collective intelligence, and overlay it on top of data? Can we bridge these two worlds, the data-driven, the knowledge-driven, top-down, bottom-up, inductive, deductive? That allows solving multiple interesting challenges. One of these is providing evidence for data-driven discoveries from literature. The other one is actually quantifying or discovering contradictions and biases in research that has been published when you have access to data. And then the third one is actually giving us for the first time the ability to solve problems where there is no data at all, by actually using the entire web as one massive database.
So it's very interesting as I hear your descriptions of hypothesis generation and knowledge generation or knowledge mining and aggregation. I think hypothesis generation, as human beings, we're quick to spot a trend in a limited set of data. But the problem is there's that cognitive bottleneck and there's a bias that comes into play. So when you have large amounts of it, we're unable to do it at the speed and accuracy that a compute engine can do. Similarly, it sounds to me that what we as human beings do is we actually take this piece of knowledge and this piece of knowledge and combine it to come with a bigger piece of knowledge. That's sort of how we have advanced as a civilization. But as that gets dispersed and that gets spread and all these different areas get to be so far apart, our ability to do that is constrained by the amount of thinking we can put in. And it appears what you're talking about is using compute engines to be able to take that additional task on and do it faster, quicker, and bring those to the table so we can then quickly make decisions on that.
Exactly. So if
that's true, give us an example of how that comes to life.
So essentially, in two ways. The first one is you have a massive problem, such as climate change. And this problem, it's sort of clear to everyone that we have a clock, there is a countdown, and we are reaching a point of no return. So we need a very different sort of machinery to address those problems. We can no longer count on someone to have a eureka moment in 5 years from now, because maybe it's too late. So we need to harness humanity's collective intelligence. We need machines that can actually learn physics, biology, game theory, how the economy works, and connect the dots, start overlaying data on top to be able to quantify and discover further patterns in it, and also learn from the last history of inventions, of innovation, in order to actually extract inventive principles and start proposing new solutions to problems, because we really need those radical ideas and we need them fast. That's what we are after actually for 2020, where we are going to launch quite an ambitious moonshot around climate change and around combining these different forms of collective intelligence, having machines and humans collaborate and having the AI orchestrate human intelligence, knowledge, computational intelligence, web, and for us, it's quite an important mission, but this is too big for us to undertake without help. So we need all the help that we can get, and I actually want to use this opportunity to invite people to join, to contribute intelligence, data, ideas for this important cause.
What an amazing piece of work. What a great example of, I think, the work that can come through the inventions and the progress you're making. And what an inspiring end. I mean, obviously climate change is such a large problem. It's a perfect one to work on. Tell me this, you've got a lot of people across the world that'll be watching this discussion. If one of us wanted to join, to participate, to engage, maybe just to learn more, what's a good place to go to learn more about this initiative?
Yes. So first of all, we are actually going to set up a website just for this,
okay,
or a section on our website.
Yeah.
In the meantime, contact us through the contact form on our website, and I promise that I will personally get back to you if it's related to this initiative. At the same time, there is going to be a massive TED event called Countdown on October 10th, 2020, I would like to invite you separately to actually learn about that event and learn how you can contribute to this.
Excellent, Sagie. We'll also post this on our LinkedIn sort of text that goes with this, so then we'll have a way to keep updated. I really would invite our audience to join and be part of this and learn a little bit more. I've enjoyed the discussions I've had with Sagie for the last few years, done a bunch of work together looking at this sort of stuff. I have to say that the ability for us to use AI to solve for problems that we have not yet been able to crack is just amazing. And applying it to these new, innovative, large problem sets is the key to that. Sagie, thank you for joining us. What an inspiring story. An entrepreneur, a CEO, started as a boy with a dream, and look at where we are today. And I think the concepts of hypothesis generation, it's true and played out in the many examples that I think it's shown productive use in. The notion of knowledge mining and building these higher level pieces of knowledge, fantastic, and we'll track the work you're doing with the climate change. Thank you again. Thanks to our viewers, and we'll speak soon.
Thank you, Sanjay.
Bye-bye.